All right, so we're going to look here at 2.2, which is one-step equations. And I know most of you guys go, oh, I know how to do one-step equations. And I understand that, but what we're going to do is we're going to look at actually, making sure we have an understanding on how we do it. We want to make sure you understand what are the steps to get the variable by itself. That's the big thing you really need to make sure we're focusing on. So our goals, again, you don't need to write down the goals, but you do need to write 2.2 one-step equations. Our goals are solve equations by using addition or subtraction, and then we're going to solve equations by using multiplication or division. All right, so again, it's 2.2 one-step equations. So when we're solving equations, we want to make sure we use the inverse operations. And what I mean by that is you always want to think opposites. So the additive inverse, we're thinking subtraction. Subtraction inverse, we're thinking addition. Those will help us with solving and what we need to do to get these variables by itself. So when we see addition, most of the times we're going to think subtraction. When we see subtraction, most of the time we're going to think addition. So let's look at some examples. So example 1, let's solve using addition. So if we have the equation h minus 12 equals 27, our goal is we want to get h all by itself, because we want to figure out what value we can plug into h to make this statement true. So we see subtraction, so we're going to use addition. That's why we're going to solve using addition. So we're going to add 12. If we add 12 to the left side, we have to add 12 to the right side. Negative 12 plus 12 turns into 0, leaving us with h equals 27 plus 12 is 39. And then we circle our answer. How you can check, and one really cool thing about solving equations, you can always check to see if your answer is correct without even using an answer key. Because it says h equals 39, we can take that 39 and plug it back into h. So we could do 39 minus 12. Well, 39 minus 12 is going to give me 27. And since I got 27 here, and I have 27 on this side, we know we did it correctly. So again, you can always check to see if you did it correctly. So there should be really no excuses if you do get one wrong, because you should be able to check your answer. So let's look at a couple more here. We have j minus 87 equals negative 3. Well, we see subtraction. We want to get j by itself, so we're going to add 87. We're going to add 87. These go away, leaving us with j equals, well, negative 3 plus 87. Here's these adding integers, and we would get 84. So j equals 84. Again, I can substitute 84 back in for j. I can do 84 minus 87. And if I do 84 minus 87, I should get negative 3. Now let's look at one more. This time I put the variable on the right side of the equal sign. We still are going to follow the same rules. It doesn't matter what side of the equal sign the variable is on. We need to just still follow the same rules. We see a variable minus 25, so we're going to add 25. We're going to do the inverse operation of subtraction. If I added 25 on the right, I have to add 25 on the left. These 25s go away, leaving us with g equals 113 plus 25 is going to give us 138. Circle our answer. Be proud of the work we did. We can plug 138 back in for g. 138 minus 25 is going to give us 113. So what I want you to do now is I want you to try these two on your own. So pause your video and try these on your own. All right, so when you solve both of these, for the one on the left, h minus 102 equals negative 99. You should have gotten h equals 3. And then the one on the right, negative 6 equals p minus 29. You should have gotten 23 equals p. If you were to wrote p equals 23, that would have been okay as well, right? Some people like to have that variable on the left side. So now let's look at solving using subtraction. We talked about those two inverse operations. So this one, we see c plus 102. When we see addition, we think subtraction, we think opposite. So we're going to subtract 102 from both sides. And then you get c equals, oh, I gotta do the math. So then we do 36 minus 102, and we get negative 66. Remember, you can plug this back in, negative 66 plus 102, you should get 36. Let's look at our next problem. Negative 12 equals p plus 16. Again, the variables on the right side, we still do the same thing. We're going to subtract 16 from the right. We subtract 16 from the left. We're left with p equals negative 28. This one's a little tricky. It says 27 plus k equals 30. All right. This is still thinking inverse operations, but now we're really looking at this 27. We really want to get k by itself. So how can I move this positive 27 to the other side? Well, since it's a positive 27, we're going to subtract 27. We want to turn it into 0. And if I subtract 27 from the left, we have to subtract 27 from the right. And then you're left with k equals 3. And you can plug this back in to double check. 27 plus 3 will give us 30. Right? So this is using subtraction to solve, using the subtraction inverse property. All right, so I want you to try these on your own. So please pause the video now so you can try these on your own. So you should have gotten on the left, negative 11 equals x, or x equals negative 11. And on the right, you should have gotten k equals negative 16. All right, so now we're going to use multiplication or division. Right? And so here we're thinking inverse operations of multiplication and division. I didn't have these written down, but remember to think opposite. Opposite of multiplication is division. Opposite of division is multiplication. So if we look at the first one, 39 equals negative 3r. Well, the negative 3 next to the r, when you have a number next to a variable, it means multiplication. So to undo multiplication, we're going to divide. And we're actually going to divide by whatever number it is. So since it's negative 3, we're going to divide by negative 3. If I divide by negative 3 on the right, I have to divide by negative 3 on the left. So then we're left with r equals 39 divided by negative 3 is going to give us negative 13, because a positive and a negative is a negative. If we look at the one on the right, we have a over 9 equals 5. Don't think of this as a fraction. Think of this as a divided by number. Remember, a fraction bar means division. So to undo division, we multiply. Multiplies cancel each other out. Multiply by the right. So we're left with a equals 45. So again, we can plug these back in to solve. 45 divided by 9 is 5. Negative 3 times negative 13 will give us a positive 39. Now let's look at this one. 2/3 cubed equals 1/2. So here we have 2/3 times cubed. If we remember, to undo multiplication, we divide. But when we divide fractions, we actually are multiplying by the reciprocal. Remember the keep, change, flip. So rather than dividing by 2/3, we can actually multiply by the reciprocal of 3/2. That makes these 3's cross cancel, these 2's cross cancel, leaving us with just q. If I multiply by 3/2 on the left, I have to multiply by 3/2 on the right. Nothing can cross cancel, so now I just multiply. 1 times 3 is 3. 2 times 2 is 4. So then Q is 3/4. So when you see the fractions, just think multiplied by the reciprocal. So I want you to try these 3 on your own. So pause the video now. All right, so if you solve these on your own, you should have gotten H equals -7. You should have gotten A equals -27. So you're multiplied by 3 on both sides. That is a 3 right there. Welcome to a board that was apparently uncalibrated in the corner. And then down here, you multiply both sides by -5/3, and you end up getting Q equals -28/3. So that is solving one-step equations. If you do have any questions, you're like, hey, this one didn't make any sense to me. Make sure when we ask if there's anything you need clarified, make sure you do ask that question.